For those of you that don't know me, I'm Mehul Shah. I'm the General Manager of Search Services at AWS. And today I'll be talking to you about how you can easily build, secure, and share data in S3 data lakes with AWS Lake Formation. To get started, let me just give you a quick overview of my talk. First, I'm just going to give you an understanding of why customers are moving to data lake architectures and give you an overview of AWS Lake Formation service itself. For the bulk of the talk, I'm going to be speaking about some new capabilities within Lake Formation that really make S3 look like a database. Now, it's not a database, but it make it look like a database, and it's super useful for data lakes. And then I'm going to conclude. So let's go back in time a little bit, about 30 years ago. And around that time, most enterprises had most of their operational data sitting in structured relational databases. And they would take all of that data through a unified sort of ETL process, or merge all that data into a single place called an enterprise data warehouse. It was an information hub for the business, if you will. And they would run queries or analyses over this data with BI tools to get an understanding of how their business was doing and to optimize that business. So all of the decision-making in an enterprise revolved around the enterprise data warehouse about 30 years ago. But increasingly, this architecture is starting to show its age and is evolving. And there are three main reasons for this. The first one is that the data that customers want to manage and analyze no longer fits cost-effectively into a data warehouse. There's a lot more data than people think. And the data is much more diverse. If you take a look across our customer base, the amount of data that customers are storing is growing about an order of magnitude every 5 years. And so when they go and deploy a data platform, which is supposed to live around 15 years, that platform has to scale about 1,000x. The data that they're managing is also much more diverse. It's no longer just structured data, but they also want to manage unstructured text, video, as well as a lot of semi-structured data like logs, application logs, network logs, social networking feeds, and so on. And data warehouses just no longer can kind of manage this kind of data effectively. We also see that enterprises wanting to sort of unbundle their silos, break down their silos, and make that data accessible to more people within their organization. So there are a lot more personas. It's not just business users, but also data scientists that want to get access to enterprise data. We have a line of business users, product managers, DevOps professionals, and so on and so forth. And they're doing more than just SQL analytics. Obviously recently there's been a big resurgence of machine learning. There's a lot of scientific analyses people want to do, as well as real-time and streaming analysis. And as this data is made more accessible, it's democratized across your organization, there's a tension with regulations that are governmental regulations, as well as business regulations in specific industries. For example, HIPAA, FedRAMP, SOC compliance, these are all industry regulations. And then recently there's been privacy regulations put in through governments with hefty penalties like GDPR and CCPA. And so instead of using sort of a centralized data warehouse, we see a lot of our customers moving to data lakes. This is the new information hub. It's a centralized, secure repository that enables you, the customer, to govern, discover, share, and analyze both structured and unstructured data at any scale. Okay. And what we see our customers deploying is this new type of architecture, not a data warehouse, but a lake house architecture. Now, this isn't just taking a data warehouse and slapping it together with a data lake, but really it's a holistic architecture. At the center of it is a data lake. This is where people are pouring in all their data sets, unstructured and structured. And then around it, there's still a need for various purpose-built data services that are optimized for specific use cases so that you can get the best performance and cost effectiveness that you're hoping for. And what they're doing, or what we're helping them do, is make sure that the data movement between these purpose-built services and the data lake is seamless, as well as giving them tools to make sure that the movement across these engines is also seamless. We also want to give them a unified governance model so that they can manage their, manage their permissions and their security and auditing all in a central place. And of course, do this in a cost-efficient and performant way. Within AWS, the tools that we have to enable these architectures include the purpose-built services, which we've been doing for decades now. Aurora, for example, is our relational database service. DynamoDB is our NoSQL service. Amazon SageMaker is our ML service. Redshift is our data warehousing service. Amazon Elasticsearch service is our log analytics services. And Amazon EMR is our big data service. And then at the center, most of our customers are building their data lakes using and building it on top of S3. And this is why I'm here talking to you. They're using Glue to do the seamless data movement, and they're using Lake Formation to organize all of this data and secure it and share it. We have more data lakes on AWS than anywhere else, really. We have tens and thousands of customers building data lakes on AWS from a variety of different verticals, from internet, mobile. We've got, financial services companies, we have retailers, and so on and so forth. All right, so what's Lake Formation? Well, Lake Formation is a fully managed service that enables data engineers, data stewards, and data analysts to build clean and secure data lakes in days. This used to take months and months, very much like the sort of the traditional ETL process. What does the solution stack for Lake Formation look like? Well, at the core here is, of course, Amazon S3. That's our data. That's sort of the data lake storage substrate. Why? Well, first, it's ubiquitous. It's everywhere. You can access the S3 from anywhere, and it's highly available. It's cost effective. It's highly durable as well, with 11 nines of durability. So whatever you put in there, pretty much almost guaranteed to stay there. And there's a bunch of tools that are built around S3 to make it easy to manage all of the data in there. We've added another tool. It's called Lake Formation. Okay, it has two main components to it. The first component is a bunch of tools to ingest and clean data that's into your data lake. So that way, your data lake can actually have sensible data that you can make inferences with, and that you can get insights from. We've got Glue for it builds on Glue to be able to do the transformations. Blueprints, which are basically templates to create long-running and complex ETL workflows. ML transforms to make cleaning a little bit easier and automatic. But more importantly, the way customers use Lake Formation is that they represent the data that they have in their data lake like they would represent as tables and rows and columns in the database. And to sort of organize and model that data, they use the Lake Formation data catalog. It's really just pointing to the data that's sitting on S3. In addition to the data catalog, Lake Formation allows customers to provide a central place for managing permissions on all of this data, these tables and databases that are effective from the data lake store. And these fine-grained permissions are at the level of individual columns and now also individual rows. So you can effectively share this data by just doing simple grants and revokes without having to copy this data everywhere. And then finally, there are, of course, a number of integrated services that enforce Lake Formation's fine-grained permissions, from BI tools like QuickSight to ML services like SageMaker. We got thousands of customers managing petabytes and petabytes of data using Lake Formation today. Here's sort of a sampling of some of these customers. We've got insurance companies, again, retailers, media companies, and so on and so forth. So it spans the gamut. One example is OneFootball. They're a fantasy soccer company. And what they're doing is they're using Blueprints to gather all the information for 200 different fantasy leagues and bring it all together to their central data lake. And they tell us it's really simple with Blueprints to get their data organized into their data lake. FanDuel is another fantasy sports company, and Macromill Group is a digital marketing company. And both of them are using permissions with Lake Formation to hide PII data that's sitting inside their data lake. All right, so for the past year and a half or so, Lake Formation has been launched. We've launched over 20 new features and a bunch of new regions that we've added. But our customers still have come to us and told us that managing data on S3 data lakes was still hard. They're doing more with it than we originally anticipated. One of the things that they're doing is they actually want to store a lot of streaming data and update that data very quickly. Now, this is hard to do. S3, as you know, is a large object store which has immutable objects. And so if you want to do things like database replication or adhere to privacy regulations, you've got to somehow find a way to efficiently modify those objects. And so they're having trouble doing that themselves. They want to share their data in a much more fine grain, not just at the column level, but also at the row level. And as their data lakes are evolving, what they're finding out is the data structures that they have on their data lakes are suboptimal. They sort of periodically have to kind of tune them up. And so we recently added 3 major capabilities within Lake Formation: transactions, row-level security, and acceleration, which speed up and govern access to your Amazon S3 data lake. These capabilities are actually embedded inside of or behind a brand new set of update or write and access or read APIs. These APIs are open and they're public. So not only do we have access to this data in a secure way through all of these various integrated services, but you can also have third parties access the same data, get a consistent set of results, as well as it allows you to build your own applications. These APIs support atomic, consistent, isolated, and durable or ACID transactions. They support row-level filtering for fine-grained security. And they support a number of optimizations for organizing the data on S3 to make analytics fast. So I'm going to go through each one of these features briefly, motivate them, why we need them, and then give you an example of how people are using them. So why transactions? Why do customers want to run transactions on S3? Well, it turns out that we found our customers running very complex ETL workflows to ingest data into S3. And because they were trying to do updates, it would take a while for these updates to settle into S3. And so this was both a expensive, brittle, and error-prone process. And the data that they were able to then query, because it took time to settle, wasn't fresh. Sometimes it'd be 15 minutes at a minimum to sometimes hours out of date. We also see customers wanting to update these individual S3 objects that comprise their tables to adhere to privacy regulations like GDPR and CCPA. And doing that all the time requires them to kind of read and rewrite those data sets, these files all the time, resulting in write amplification. And so what we did is we introduced transactions to make it easy to build applications on S3 data lakes. These transactions allow for concurrent insert, updates, and deletes in your S3 data lakes that appear immediately. Now, the way we deliver these transactions is this new type of table that we've introduced called a governed table in Lake Formation on S3. Okay. Governed tables support ACID transactions over both metadata and data. What transaction basically gives you is a sort of an isolated view of your data lake. You can start a transaction, you can do multiple operations over your entire data lake, over multiple tables. Many users can be running these transactions at the same time, and they can be running transactions from various engines. And you get you basically can run these things in parallel, as often as you want, and you get a consistent view of your data, and you get a consistent updates to your data lake. The cool thing about governed tables is there's no lock-in, right? All the data actually remains in customers' S3 buckets. They retain control over their data, and the data is actually sitting in Parquet, in open file formats like Parquet or JSON. We make it easy to import and export data from a variety of different other table formats, like, for example, Hoodie or Iceberg, in and out of governed tables. And because governed tables keep track of every update that's happening to your data lake, you can actually access a version of your data lake as of a previous point in time. We call this time travel. To see how this all works, let's take a look at what traditional tables on S3 look like, or traditional data lake tables look like on S3. These are Apache Hive style tables. Typically, the way that these tables are organized as they're just a collection of files which contain the rows and columns. And these files are organized under partitions, or really just S3 paths. In this case, we have data that's organized by region, year, month, and day. Now, a governed table is basically the same set of files. We don't actually move any of those files, but we ingest all of the metadata into this thing called a manifest that's sitting behind the Lake Formation APIs. And it's this manifest that we allow you to update and modify. And the cool thing about this approach is that now import and export is super easy and simple because you're only moving metadata. You don't have to move petabytes of data to get data into a governed table. Let's see how governed tables work. Imagine, for example, you have a manifest here that's represented. There are two transactions. Let's call them an orange transaction and a blue transaction. And you're using our APIs to update this manifest. Well, we're going to order the transactions for you. And depending on which order they commit in, you're going to get a new version of the manifest. So in this case, the orange transaction committed, and you get a new manifest. It's version number 2. And then you have a blue transaction that commits, and you get yet another version of the manifest. And so as we have these various data structures behind the scenes that allow you to efficiently represent these manifests, and they also allow you to go to a previous point in time very quickly, right? Almost instantaneously. We also support row-based updates. So if you want to actually do inserts, updates, and deletes in these rows, the way we represent those things is you have your base data in your table, in your governed table, and all of the changes are going to be stored on the side as delta records that are sitting, or delta files that are sitting on S3. And so as updates are made, you're going to get additional delta files, and as you do reads, these things are going to be merged on read. Let's take a look at how transactions, what it actually looks like to use a transaction. What we're going to do is we're going to run 2 notebooks. They're going to be running, running over an Apache Spark cluster that's using Lake Formation transactions behind the scenes. One of them is going to be doing updates, and the other one is going to be doing reads. Okay. Let's set up the transactions here. We're just setting up the data structures here. We're going to start a transaction on both sides, notebook 1 on the left, notebook 2 on the right. And we're going to actually read the tables here. And what you'll see is both of these notebooks are seeing the same thing. They're just referencing the same table. Now, because transactions see an isolated view of the data, when you modify the data, in this particular case, the previous slide here, we added 2 records to the products table on notebook number 1. It basically gets an isolated version, or sort of a scratch pad that it can work with, if you will, where it's going to make modifications to the data lake, but nobody else is going to be able to see it. Okay, and so that's what you see here on the right-hand side. Notebook number 2 sees the original table, and notebook number 1 is still kind of working with the first table. Now, after you commit the transaction, that's when the updates are reflected across the data lake for all of the other users, or all of the other notebooks that are running at the same time in this example. So when you run another transaction, they're going to see the same data. Now, the really cool thing is that, regardless of whether you have some, concurrent transactions, certain transactions running and aborting because of failures, or any other things that could possibly screw things up, the state of your database is going to stay consistent, because they're always going to work on sort of a snapshot of sort of a private snapshot until things are committed, and the commitment happens atomically. So that's really the nice thing about transaction. It makes building applications on your data lakes much easier. Huddle, which is a performance management company, so they manage performance of sports coaches and athletes. They're actually using this to analyze a whole bunch of video and sports footage. They're actually using this Lake Formation to ETL that data and produce trustworthy data in their data lake. All right, so let's talk about row-level security. Why do people need row-level security? Well, it's simple. If you don't have row-level security, sharing data actually requires you to copy that data and redact the subsets of the data that you don't want to share. So as an example, imagine you're in a healthcare situation, you have patient records. Admins should be able to see all the records, but doctors and nurses should only be able to see their patients. Or maybe a retailer wants to treat store managers and regional managers differently. With Lake Formation, you can share this data without actually ever having to copy that data. We allow you to grant permissions to a table to other users within the account, or other users across accounts, without ever having to copy things at the level of a table, at the level of a column, or even at the level of a row. The way you specify a row level filter, a row level security policy, is you specify a filter that's effectively a where clause in your SQL query. The variant of SQL that we use is called particle, which is a superset of SQL. And our row-based security actually supports many different types of table formats, not just governed tables. Because all of these security policies are in a single place, you can audit the permissions across your organizations, and you can also audit all the accesses that happen, which is a very nice, easy way to get governance across your data lake. Okay, let's take an example of a row-level security. The setup here is AWS CloudTrail data. CloudTrail basically organizes all of your API requests into and sort of records it into a single S3 bucket. And API requests here are AWS services like Lake Formation, EC2, and S3. Imagine you have a compute admin, for example, that should only have access to the EC2 records, a data admin that only should have access to Lake Formation records, and a storage admin that should only have access to S3 records. In that case, with Lake Formation, you simply specify the principal, in this case, the compute admin, the resources, in this case, it's the entire CloudTrail table that we have, and the row level filter, in this case, EC2 records for the compute admin, S3 records for the storage admin, and Lake Formation records for the data admin. Then when these admins come in through a service like Athena allows you to run SQL, for example, over S3. Those admins are only going to see the records that are relevant for them. The compute admin sees EC2 records, storage admin sees S3 records only, and the data admin sees Lake Formation records, even though they're working over the same table. All right, we got a couple of two additional capabilities, and I'm not going to have a ton of time to go down to kind of discuss. One is the ability to actually push down additional predicates beyond just security filters, and as well as aggregations into the Lake Formation API, so you can run those filters closer to the data. We found that when people are running queries over their data lakes, they were dropping more than 80% of their data. So this actually speeds up their queries a lot, as well as makes those queries a lot cheaper. We also have a storage optimizer that automatically compacts files, small files, into larger ones or right-sized ones for analytics, and merges deltas in so that you're not constantly merging on the read path. Because Lake Formation allows you to share this data across accounts as well as across organizations, there's a completely new set of use cases that it enables. We see a lot of customers build centralized hub and spoke topologies, for example, for sharing their data through their data lakes. We see them sharing data across organizations and across companies, for example, vendors and suppliers, aggregators and distributors. And there's also various peer-to-peer sharing arrangements, which they call data meshes. A simple example of what we were able to do with Lake Formation and Glue is set up a public COVID-19 data lake where we are storing a whole bunch of public information about the COVID-19 pandemic from places like Johns Hopkins or Carnegie Mellon University. And we were able to stand this up in literally 2 or 3 days. And our customers are using a variety of engines, including ML engines like Comprehend and Kendra to analyze that data, as well as traditional SQL analytics engines like Athena and BI engines like QuickSight. All right, so to conclude, Lake Formation started as a tool to help engineers and stewards and analysts build clean and secure data lakes. since then, we've added a whole bunch of new APIs that allow you to do transactions on S3, provide a unified governance mechanism for your data lakes, and accelerate accesses to S3 for analytics. There's no lock-in with these new APIs. You retain control of your data. It supports open standard formats and allows you to efficiently share that data. And so not only are these integrated services that work well with Lake Formation, but now you can bring in third parties as well as roll your own applications directly on your data lake. So Lake Formation now has become the foundation for analytics on data lakes on S3. So with that, I'd love to take questions or thoughts that you have. Just curious as to what you think about how S3 is evolving 15 years since we launched it.
Yeah, well, thank you very much for that enlightening presentation. We have a couple of really good questions in chat, specifically around this concept of row level security that you were talking about toward the tail end there. Sure. And I think chat astutely points out that S3 stores files. What is the concept of row level security at S3, or is it a lake formation concept?
So the row level security is a lake formation concept. So if you take a look at lake formation, the way it works is it organizes data on S3 in terms of tables, and the tables have effectively columns and rows inside of them. And the tables are actually comprised of all these S3 objects, but you don't actually never have to worry about that. The security basically says, if I'm reading that table through the lake formation APIs, which records do I get back? Okay. And so as long as you go through the lake formation APIs to access those S3 objects, you're going to get back individual records, and those records are going to be in the arrow format. And so there's a standardized format that we return those records in. And it's an open standard that a bunch of other engines actually use in turn.
Okay, so and then a related follow-up is, how exactly do you maintain this kind of row level security, right? So let's say as the data changes, as you get data in S3 that, let's say certain files are missing certain fields, certain files have new fields. You want to kind of, I'm filling out some blanks here, so this is my interpretation, but yeah. How do you manage that kind of row level security over time?
Yeah, I think it's a great question. So the policies that our customers will put in are actually very flexible policies. They're not going to be like, hey, this record number should not be shown to Robert, or this, like, it's not physical, it's logical. So they come in and they say, hey, Robert only gets to see the records for, everything that's happening on his street, for example. And you'll express that as a predicate. You'll say where street equals, Jane Boulevard or something like this, right? And so when Robert tries to access this data through any one of these engines are going to go through the APIs that Lake Formation has. And Lake Formation, when it goes and reads that data, it's going to read it on demand, and it's going to filter it on demand for you. So regardless of what that data is, regardless of how it changes, as long as the Lake Formation service can interpret that data, it's going to go and actually apply those policies in situ. It's going to be inline filtering that's going to happen. So it doesn't matter actually what happens underneath to the data. It can change as much as it wants.
Mm-hmm. And for my edification, when you refer to these policies, can I express these row level security constraints in a standard IAM policy?
So you can't do it inside of a standard IAM policy. So all of the security is actually a security layer that is alongside IAM. So IAM will allow you access to Lake Formation and all of the data structures within Lake Formation. And then as you go inside of Lake Formation, we apply a bunch of security policies that are inside of Lake Formation. So you express them as SQL statements, but you do them as grants or as revokes inside of Lake Formation. So they're on the side of IAM, not inside it, IAM.
I see. So it's almost like your IAM policy is defining concepts like what Lake Formation operations you're entitled to perform, and then Lake Formation is kind of getting down into the weeds in terms of what row level security and other policies that you might have within Lake Formation. Is that right?
That's exactly right.
All right. Well, Mehul, I think we have to move on to the next section, but this has been fascinating for me. I mean, just the very concept of governed tables to me seems like it's a total game changer. We'd love to, talk shop with you at some point in the future. But the show must go on. Thank you very much, Mehul.